Welcome to Brain Vision.
So given the surface S, and we know the equation z equals g of xy, what we're going to do is use this formula right here so we can calculate the surface integral f of xyz ds is going to be equal to the double integral over the region of f x y g of xy times the square root of the partial derivative of g with respect to x squared plus the partial derivative of g with respect to y squared plus 1 dA. So with that, we write the equation of the plane that we're given as z equals 4 minus 2x minus 2y. And with that, we take the partial derivatives, and now what we end up having is that this is going to be equal to the double integral of xz ds, which is then going to be equal to the double integral over the d region of x times 4 minus 2x minus 2y times the integral of negative 2 squared plus negative 2 squared plus 1 dA. So that's just the integral, or the 3 times the integral over the d region of 4x minus 2x squared minus 2xy dA. And since that is just part of the plane in the first octant, we are going to rewrite the equation of the plane in intercept form. So that's going to be x over 2 plus y over 2 plus z over 4 equaling 1. And we see that x and y intercepts are both 2. So the D region is going to be a triangle, a right triangle with vertices 0, 0, 2, 0, and 0, 2. So with all this information, we know that x is between 0 and 2, and y is between 0 and 2 minus x. Then we can now evaluate this integral. The bounds of integration will be from 0 to 2 and 0 to 2 minus x with a 3 out in front. And then what we have is 4x minus 2x squared minus 2xy dy dx. We evaluate the first integral, and what we end up getting is 3 times the integral from 0 to 2 of x times 2 minus x squared dx. And then depending on whatever property you use, you could use substitution method or something like that. And what we end up getting as a result is going to be that this is equal to 4. So that will be our final answer for the surface integral.